All right, so today we're going to look at more complex rational functions and how to graph them. And to graph them, we have to find asymptotes, we have to find holes, and we have to find more points. And I'm going to use the graphing calculator also as a tool to find a lot of that. So a rational function is basically just a function that's got polynomials involved on the numerator and the bottom and the top. And the domain is going to be all real numbers except where the denominator is equal to 0. Now these are examples of rational functions. Rational functions can be continuous, meaning they go forever and ever without any holes, breaks, asymptotes, or anything. So this is continuous. It goes on, there's no breaks. Okay, this second one is discontinuous. Okay, with a hole for its discontinuity, because it does not exist where there is a hole, and this circle right here means there's a hole. This is discontinuous because it doesn't exist at x equals 2. Okay, so you have that asymptote here, and we call this an infinite discontinuity. Right, there's a lot of steps to graphing these equations. I'm going to just let you pause and read it because it's just, like I said, a lot. Okay. Horizontal asymptotes, I do want to explain a little bit. If I have a function like y equals x squared plus 3x plus 1 over x minus 3, okay? The degree of the top is 2, because that's the highest exponent. The degree of the bottom is 1. So that's what we're looking for to decide on the horizontal asymptotes. If the degree of the bottom is less than the degree of the top, okay, or the degree of the top is less than the degree of the bottom, then the x-axis is our horizontal asymptote. If it's greater than, the degree of the top is greater than the degree of the bottom, there is no horizontal asymptote. And then if they're the same, what we do is we take the coefficient. So let's say that this was a 3 here. My horizontal asymptote would be y equals 1/3, taking the leading coefficients. All right, so first step to do when I'm graphing is to factor. So the top can't be factored, but the bottom of my function can be factored to x minus 5 and x minus 1. Since none of my factors cancel, there are no holes. Okay. My vertical asymptotes, I take my bottom and I set each of those factors equal to 0 and solve them. So x equals 5 and x equals 1. So those are my vertical asymptotes. It's where graph doesn't exist, and that makes sense because if either of those are 0, then my function does not exist. My horizontal asymptote, the degree of my top is 1. The degree of the bottom is 2. So that means that my horizontal asymptote is x equals, or y equals 0. It's the y-axis. To find my x-intercept, you would put 0 in for y and solve. Well, I would do that by multiplying this, both sides, by this, and it would give me 0. So basically, we're just going to take our numerator and set it equal to 0 to give me the x-intercept. So x equals -3, and that's the ordered pair, -3 and 0. To find my y-intercepts, I'm going to put 0 in for x and solve for y. So these all cancel, and I get 3/5. So my y-intercept is going to be 0 and 3/5. And then we're going to use the graphing calculator in order to find more points. Okay, the graphing calculator is going to be a great tool so that we can look at a general shape of an equation and we can get more points. So I'm going to go to graph and I'm going to enter in our function. It's already entered in. Make sure that you have parentheses around the numerator and the denominator so that you can, otherwise it's not going to give you the correct function. And then I'm just going to draw it. And so here's what my function looks like. This little line right here is actually an asymptote. It doesn't quite show on there. But our shape is the two curves here and this curve right here. Okay. Now to get more points, I'm going to go back out to menu and I'm going to go to table. And the nice thing about the Casio is it's already saved there. If I press set, it's going to tell me where I want it to start, and I can change that if I wanted to start it whatever I wanted to start. Step means what increments do I want to go. So I'm going up by ones. So I'm going to now go back out and hit table, and there are all kinds of different points, and we can see the different points. You can see that at 1 it gives me an error because that's my vertical asymptote. And then it also gives me another error at 5, which is my vertical asymptote. Right, so on the next slide, I'm going to have these points written down so that you can kind of see what they are. All right, so here is all the information that I gathered about this graph. I took screenshots from the graphing calculator. This is all our work we've done. There is no hole. I have a vertical asymptote at x equals 5. So I'm just going to draw a dotted line to show that. And I have one at 1. And then I have a horizontal here. Now the weird thing about horizontal asymptotes is it applies to at least one branch of our graph. It does not necessarily apply to all, which is where we get that x-intercept of -3, 0. But it's going to be really, really close to that. All right. We have a y-intercept at 0 and 3/5, which is a little bit more than a half. Okay, so there's 2 points for our branch. On this case, we saw that when we graphed it, it kind of made this shape. So that's what we're going to replicate over here. So this is going to go here and shoot up there. Okay, when I go to 2, I get -1 2/3. When I go to 3, I have -1 1/2. 4 is -2 1/3. So right about there. So this is going to look like this. Okay. And then at 6, I've got 1 1/8. So right about here. And 7 is a little bit less than 1. So it's going to look like this. So there is my graph. Now, if you don't have a graphing calculator, you can always substitute in points so that you could find the shape of that graph. All right, so now in this example, the first thing I'm going to do is I'm going to factor. I'm going to factor the top to x minus 2 and x plus 2. And then the bottom, I can factor out a 3, and it's x minus 2. So the x minus 2's cancel, and I'm left with x plus 2 divided by 3. Okay. The x minus 2, I'm going to take that and set it equal to 0, so I have a hole at x equals 2. Now, what's left is here. I don't have anything I can solve for my vertical asymptote because 3 equals 0, so that means that there is no vertical. The horizontal, the top degree is 1, the bottom of the degree is 0, so there's no horizontal. My x-intercept, if I put 0 in for y and solve, 0 equals x plus 2. Actually, just the top is all I need. X equals -2, so my x-intercept is -2, 0. My y-intercept, if I put 0 in for 3, that gives me 2/3. The other thing that you can do is this is just linear. It's just really y equals 1/3 x plus 2/3. So I'm going to go to 2/3, and then I've got a slope of 1/3, so I'm going to go up 1 and over 3. Up 1 and over 3. Now, when I graph it, remember I've got this hole at 2, so I'm going to get close to 2. I'm going to draw a circle, and there it is. All right, last example. I'm going to factor again. So the bottom, top can't be factored, but the bottom factors to x times x squared minus 4. These x's cancel, so I have a hole at x equals 0, because I would set that equal to 0. And then the bottom factors to x minus 2 and x plus 2. Okay. My vertical asymptotes, I set these equal to 0, x minus 2 equals 0, x plus 2 equals 0. So x equals 2 and x equals negative 2 are my vertical asymptotes. Because the top is greater than the bottom, the degree of the top is 1, the degree of the bottom is 3. It's y equals 0. My x-intercept if I were to put 0 in for y, I'm going to get 0. Okay. But if we look at the graph, you could graph it, it's not going to go there. And then my y-intercept, if I put 0 in, for x, it's going to be undefined because 0, the denominator will be 0. So there is no y-intercept. So here are the points from the graphing calculator and everything that I've come up with. Okay. And I'm going to go ahead and graph it. I've got my vertical asymptotes at x equals positive or negative 2. And my y-intercepts here. So I've got some points. At negative 4, it's 1/3. At negative 3, it's 8/10. At negative 2, it doesn't exist, so we're going to have here. At negative 1, we have negative 1 1/3. At 2, we have an error, but positive 1, we're negative 1 1/3. And then we don't exist at 1. So we're going to have a hole there. 3 is 8/10. 4 is 1/3. So we can see that it's very symmetrical. So there is my graph. So today, you should have learned how to find your x and y intercepts, your holes, and your more points. And we'll talk about domain and range in class. So have a math-tastic day.